Hi students, in this video I'll be going through the 2023 A Math Paper 1 question 13. Alright, so this is the last question inside 2023 A Math Paper 1 and it's on coordinate geometry. Alright, okay, so let's read the question. So the perpendicular bisector of the line joining the points A, which has coordinates 2h, and B with coordinates -8, -7, passes through the point X, which is h minus 13/2, where h is a constant. So express the gradient of the perpendicular bisector of the line AB in terms of h. Okay, so like all circle questions, coordinate geometry questions, just a simple diagram will help you to visualize the question better. Okay, it doesn't have to be a super accurate diagram. Okay, as long as it's roughly there and able to represent the information well, then it should help you to visualize the question better. Okay, so let's say this is point A over here. Okay, coordinate 2h, and then this is point B. The coordinate is -8, -7. Right, so in part A, they want you to express the gradient of the perpendicular bisector of the line AB in terms of h. Okay, so I've drawn this line over here. This will be the perpendicular bisector. Okay, so this is the perpendicular bisector. Okay, so we know that the perpendicular bisector has got to be perpendicular to the line AB, and then it cut AB into two equal parts. All right. Okay, so they want you to find the gradient of this perpendicular bisector. So gradient of this perpendicular bisector in terms of h. All right. Okay, so since the concept that we need to apply is this: since the perpendicular bisector is perpendicular to the line AB, then the product of their gradient is going to be equals to -1. Okay, so that's precisely what we are going to do to find the gradient of the perpendicular bisector. Right? Okay, so let's call this gradient perpendicular bisector. Okay, so let's find gradient of AB first. So gradient of AB. Okay, so we're going to use y2 minus y1 over x2 minus x1. Okay, so I'm going to use this one as x2, y2, x1, y1, right? So h minus -7. Okay, so remember always y on top, okay, over 2 minus -8. Right, so that will give us h plus 7 over 10. Right, so this is the gradient of AB. Okay, so the concept here is that the gradient of the perpendicular bisector times the gradient of AB, which is h plus 7 over 10, is going to give you -1. Right, so we can get the answer quite easily. So gradient of perpendicular bisector, okay, it's going to be a -10 over h plus 7. Okay, so just like this will be the answer for the first part. Okay, so don't be afraid of trying the question, although there's unknown inside like h. Okay, but just apply the concept as you have learned it inside the question, inside the curriculum, right? Just apply it, right? So hence find the possible values of h. Okay, so far if you look at this question, okay, now they want you to find the value of h, right, which is an unknown. Okay, you need to think about what is the info that we have not used yet. All right, so the next info that we have not used yet is that the perpendicular bisector, right, okay, passes through this point x with the coordinate h -13/2. So let's say x is over here. Okay, so you can just label it anywhere you want. Okay, as long as it's on the perpendicular bisector. So the coordinate is this, right? Okay, so we want to make use of this additional info to help us to find the value of h. Okay, so the thing about in math is this. You ask yourself, now we have one unknown h, right? Okay, so in order to solve for that one unknown h, if I can formulate one equation involving h inside, then I should be able to solve it. Okay, so now your main consideration will be to formulate an equation. Okay, formulate one equation, okay, involving h. Okay, then you solve the equation, you will be able to find h. Okay, so where can I get that? particular equation from. Okay, so far what have we done? So far we have found the gradient of the perpendicular bisector, right? So the gradient of the perpendicular bisector is here. Okay, we have found it. Okay, we have found the gradient of this particular line. Okay, this particular line we have found the gradient. So if only I can represent this gradient in another form, and then I equate to this gradient of the perpendicular bisector, right? Then I should be able to solve for H. Okay, so remember this point X lies on the perpendicular bisector. Okay, so now one other question. If I want to find the gradient of the perpendicular bisector in another form, right? What other piece of info do I need to know? Yes, if I know the coordinate of another point on the line, okay, then I can use this point. Okay, so let me call this M, which is the midpoint, okay, which is the midpoint of the line AB, right? The perpendicular bisector must pass through the midpoint of AB. Now, if I can find the coordinates of M, then I can use the gradient, right? I know the coordinates of 2 points. I will be able to find the gradient of MX, and this gradient of MX will also be equal to the gradient of the perpendicular bisector, right? So can I find M easily, the coordinates of M? Yeah, I can find the coordinates of M easily, right? All right, so let's find the coordinates of M now. Okay, so M is the midpoint of AB. Okay, so midpoint of AB will be M. Okay, so the coordinate of midpoint, very easy to find. Just add up the 2x coordinates, then divide by 2. Okay, then add up the 2y coordinates, then divide by 2. Okay, so if I simplify this, I will get -3. Then this one I will just reverse the thing. So instead of -7 plus here, I write h -7 over 2. So this will be the coordinates of M already. So -3 h -7 over 2, right? So this is the coordinates of M. Okay, then with the coordinates of M and with the coordinates of X, I can then find the gradient of MX, and then I equate it to the gradient of perpendicular bisector and solve. So let's find the gradient of MX, gradient of MX. Okay, so gradient of MX, same thing, y2 minus y1, right? Okay, so will be h -7 over 2 minus negative, okay, be careful, negative 13 over 2. Okay, so this one will now be y2, x2, x1, y1. Okay, so this minus this over -3 minus h. Okay, so let's simplify this thing. Okay, let's simplify. Okay, so this will become h -7 over 2 plus 13 over 2 over -3 minus h. Okay, then same denominator we can combine already, so it will become essentially becomes h plus 6, okay, -7 plus 13 over 2 over -3 minus h. Okay, right, so this will be the gradient of mx. Okay, so if I want to simplify further, then it will be h plus 6 over 2 times -3 minus h. Okay, so this will be the gradient of mx. Okay, so the gradient of mx is going to be equals to the gradient of the perpendicular bisector. Then I can formulate my equation and find h already. Okay, so that's what we're going to do. Okay, so gradient of mx equals to gradient of perpendicular bisector. Okay, so remember, whenever we want to solve for one unknown, we try to formulate an equation, right? So the gradient of perpendicular bisector just now was -10 over h plus 7. Right? Okay, so all we need to do now is we'll just cross multiply. Okay, so you'll get h plus 6 times h plus 7. Okay, I'll leave the negative sign with the -10. Okay, so I'll just bring the h plus 7 over. So -10 is still here. It will multiply with 2 times -3 minus h. Okay, so just expand this. Okay, I think I'll continue over here. So this one, continue over here. Okay, if I expand, I get h squared plus 7h plus 6h plus 13h plus 42. Okay, so -10 times 2 is -20. -20 times -3 will get 60. right? Then negative 20 times negative h, you get plus 20h. Okay, so we'll bring everything to the left side. So you get h square 13h minus 20h minus 7h minus 18 equals to 0. Okay, then we'll just factorize. Okay, so this one can be factorized quite easily. H negative 18, so we will get plus 2 and minus 9. Okay, plus 2 and minus 9. Okay, so factorize using the cross method. So it's either h plus 2 equal to 0, so h negative 2, or h minus 9 equal to 0, h equals to 9. Right? Okay, so are both answers acceptable? Okay, so if you look at the question, they say find the possible values of h. So that means they are expecting more than one answer. Okay, but actually, if you look at the question, I don't see anything wrong with accepting both answers, right? Okay, so which means that both answers can be accepted. Right, so not a difficult question. Okay, not too difficult. Okay, the first part definitely something you can do. Okay, so the second part, always remember, if you want to find the value of one unknown, always think about formulating one equation. Okay, so in this case, the equation will come from equating the gradients of mx and the gradient of the perpendicular bisector. Okay, there's really nothing much else that can be done really. Right, so I think this will be the easiest way to solve the question, right?